Welcome to the pre-recording of lecture 19, which is the first half of session 10 in the 8-week summer session. So as you can see from the slides, the purpose of this session and this entire lecture is to prepare for our midterm exam, which will happen at the end of the fourth week. So in this slide presentation, I will explain the protocol, what the midterm exam will be about, what the policies are, and then I have prepared 5 literacy questions. So in the second part of this review, we will go into Python. Okay, so let's do this. Let's look at the slides. So the main point is that the midterm exam takes place this Friday. The most important aspect of it is that you must sign up before noon on Thursday, 6 July. So this is an online course and you can take this course completely asynchronously, except for the exams. And also in this sign-up policy, I want that you have at least looked at the review. So there will be multiple versions of the exam, so that is to ensure that you will not be tempted to ask your friends for suggestions. The answers must be in one single Jupyter notebook and must be uploaded before the end of our regular sessions. So this is our sessions run from 10 till 11:40, Monday, Wednesday, Friday. So if you do decide to take the exam, then there is an action item. You have to sign up. Otherwise, if you skip the exam, then you do not need to do anything. You will simply not receive the questions via email. So there is the skipping policy. So not doing anything means that you will not take the exam. And in that sense, there might be good reasons not to do that because you may not feel well prepared enough. The course is flexible, so if you skip a midterm exam, then the points are not lost, but the final exam will count for 100 points more. So there are 600 points for this course. The final exam counts for 200 points, midterm for 100, 200 for the projects, 100 for the quizzes. So if you are skipping a midterm, then your final exam will count for 300 out of the 600 total points. So you can skip an exam. What you cannot do is look at the questions and so take the exam and then not submit anything. Then you will receive a 0. Also, what you cannot do is kind of submit something, but then when the score comes in and is disappointing, then you can't really drop that score. The score actually will count. That doesn't mean that everything is lost if you have a disappointing score, because there will also be a tendency to see if your final is then substantially better than the midterm. That bad score may not hurt you that much. All right, I have 5 questions prepared. So the first question is the question that you had on the first quiz. A number given in decimal notation. 94 is 9 times 10 plus 4. Convert this in binary notation, convert it in hexadecimal notation. So there will be two versions. So one version will be for the binary, another version for the hexadecimal. We have seen commands for this. The quickest way is to do the bin and the hex, and I would perhaps also recommend that you do this to check your answer. But in this type of question, which will be the first question on the midterm exam, you must show all the steps in your computations. I will, in the second part of this presentation, I will show my answers in a Jupyter notebook. Circuits. So everything is binary in a computer. So what we have is that everything is defined by circuits. Circuits are interesting because they are they are showing how computers work, but also it's interesting for the logical expressions. So here is a circuit. You may actually recognize the circuit. It's a circuit that defines the addition and the carry over, so the sum S and the carry over of 2 bits. What I expect from so I do not expect that in this course you will be able to draw a circuit. We have seen the diagram, but the diagram is good for flowcharts, and I will ask for a flowchart, but the diagram is not so good for circuits. What you will need to know is looking at the circuit, you will need to be able to read it. So you will have to recognize that there is a not operation in there. So this is a not operation. There are 3 ands, and there is 1 or. So, and the question is for bit 1 and 0 on input, what is the output? What is the value at the sum? What is the value of C, of the carryover? So if you know that this is the sum and the carryover, then it's straightforward. But in showing your work as well, so it would be good if you would show the logical expressions that are defined by this circuit. Truth tables. Truth tables are important because as programmers, when we have branching conditions, we have to be able to simplify expressions. So this looks like a very complicated expression, but if you make up the truth table, then this truth table will significantly simplify. This is a truth table for 2 variables. So you will list all possible combinations of x and y, and that will lead to 4 rows in your truth table. If you have a question with 3 variables, you will have to make 8 rows. So that's a mistake that is commonly made. So the examples are for 2 variables. We all have 4 rows, but on an exam there might be 3 variables, and then you need 8 rows. So then writing down only 4 rows, and you will only receive at most half of the points. Flowcharts. So flowcharts are very important, and also pseudocode. In a way, this is also the essence in computer science. Computer science is the study of algorithms to describe and transform information. So in Python, there are many built-in intrinsic operations. So if you have a list of numbers and you want to find the maximum, then it's very straightforward, max of list. So that's also the recommended way of working. So use the intrinsic operations. However, finding the maximum of a list is actually one of the basic algorithms. So if you have a complicated data structure and you need to iterate over all the elements, then that's also the algorithm that you will use. So in some sense, this exercise is very important. You must know the algorithm to find the maximum in a non-empty list of unsorted numbers. If the list is sorted, then from small to large, then you pick the last element. So you must know the algorithm, and I will solve this exercise just by first describing the idea, and then from a loose description in words, what is the idea of the algorithm, you can get the pseudocode, and then you can get the flowchart. So if you're more visually oriented, then flowcharts are very useful, especially for loops. So we have seen many flowcharts throughout the course. Very good to define algorithm. So flowcharts are pictures of algorithms. All right, last question. So this last question is a transition to Python. You have already written in this course a number of Python scripts and already encountered errors. We distinguish between syntax errors and semantic errors. There are also logic errors. So those errors are actually the hardest. So a logic error is when your program executes but gives the wrong result. In a syntax and a semantic error, the Python interpreter will complain. And in this course, we never submit scripts that do not run. So you must be capable to distinguish a syntax error from a semantic error. Syntax errors are the ones that are easiest to fix. Often your editor is already using colors to help you to indicate when something is wrong. This question asks you to illustrate the difference between a syntax error and a semantic error by actually giving two good examples. And you must have had already some good examples on your own practice. Okay, I will now go to the second part. So the most important thing is actually when you solve the exam that you think about the questions. So I have two Jupyter notebooks available. This is the first Jupyter notebook with the questions. So on the exam, I will email you a PDF file with the questions in it, but I will also email you a Jupyter notebook with the questions in there as well. So what I didn't say is that in this course we are using the Jupyter notebook in a Jupyter lab environment. You must know by now the distinction between a code cell and a markdown cell. So most of the cells are actually markdown cells. And you see the section headings. A markdown cell can contain plain text, like here, a header or a list. And we will also see tables. So in some sense, this is a review that shouldn't have anything new. So conceptually, there's nothing new. However, there might be in the making of tables, there might be something new coming up. So especially with truth tables, how you format them. So you are recommended to use the Jupyter notebook with the questions. Or however, if you decide to start from scratch and have the PDF file there, that is fine as well. But at the very least, use section headings for every question. Okay, so here are the 5 questions in markdown cells, and there is also this one picture that is displayed here with the circuit. Okay, first thing first, we always read the question. And this is an open book exam, so you could go scrolling down to Jupyter Lab allows you to open many tabs. Um, I would recommend that you would only consult the materials if you really have no clue, or that would be pretty bad. But if you want to check out something, so I have posted the solution to the quizzes. Please look at those, especially if you didn't have full credit for this question. Okay, so let me go then to the other notebook. So how do you convert to binary notation? So to binary notation, you will repeatedly divide by 2. So you initialize your number to 94 here, and then you run. So there is the copy and the paste. Each time, so you can do this in different cells, but here this is most useful if you print and do the quotient and the remainder computation in one cell. So you can read off, the number actually gets smaller and smaller. So this is a loop. So the last step, and I can probably put everything so that you can see everything in one. So this is in one screen. So you see the algorithm continues repeatedly dividing by 2 until the quotient equals 0. We compute the least significant bit, the first remainder is all the way at the very end. So this is an even number. So also important when you run the algorithms, does it all make sense? So this is an even number. 94 is an even number, so we have a 0. 47 is an odd number, so you have a 1. So whenever you see an odd number, an odd quotient from the previous step, you will have a 1. Until here you have a 2, then you have a 0. You must write at least one sentence. What is the final answer? So I must see that you understand it, that you just didn't do some copying and pasting. Of course, if you ever have to do this, there is the bin. So here is the bin. So you will receive no credit for, so if you ask, for example, ChatGPT or anybody should actually give you this is the answer, but you must show all the steps. So you must run through all this, and you must show the output. You must show that you understand what comes out. So this is one version of the exam. The other version is on converting into hexadecimal notation. You may now immediately say, hey, it's unfair. I will have to do so many steps. So here you see that it goes a lot faster. But it's a little bit more confusing because with the bits it's 0 and 1. Here you have this 14 that comes up. So you cannot write 514. So you have to know the hexadecimal notation of the first 15 natural numbers. So when you see 14, you have to remember that we start 10 is A, so you can count on your fingers A, B, C, D, E. 10, 11, 12, 13, 14. So we translate 14, we write it as an E. Also, just like with the other algorithm, the least significant digit comes first. And now it's harder to see unless you are really very good with mental arithmetic. It's very harder to see, harder to check the output, whether you did something. So in the previous um, conversion, we saw whether the number were even or and odd. Here, actually, dividing by 16 is not something that you regularly do in practice. Again, also check the answer. So you may receive some credit for doing hex. So this could be here very useful if you, for example, you thought that 14 is D and not E. So this will be the check then. Okay, second question. Second question is the circuit. Again, let's stare at the question a little bit, or let's stare at the circuit. The not operations are these triangles and a dot. You see that they actually have three inputs, or that the bits are actually fed 3 times to different circuits. The not is a unary operation. There's only one input coming in. The and is binary, and I didn't make up those symbols, so it's a little bit subtle between the or and the and. So there is some curliness going here between the and the or. So as the review, I put up a very famous circuit. So this is for the sum and the carry over. So if you recognize this from the lectures, then it's very straightforward. And that is also how we are going to solve this exercise. We're going to look, and actually you can see that the C is defined by only one operator. And you can, for example, forget about the whole other stuff. First compute the output of C, and this is an AND. We have a B1 coming in. B1 is 1. B2 is 0. 1 and 0 logically is 0. It's not 1 plus 0, but is the logical AND. The AND is only giving you 1 when both operands take the value 1. So in solving this exercise, you will read the circuit. Reading the circuit is translating the symbols into logical expressions and substituting. So you first show, so in some sense, the final answer is C equals 0 and S equals 1, but you must actually show how you got to there. This is also to help you, because if there is something wrong, if you evaluated these expressions somehow wrong, then you can still get partial credit. So more than half of the exercise is actually the translation of the picture into the logical expressions. Okay, evaluation of logical expressions is important. As a programmer, we do this all the time if we design our if-else statements. So it has an important connection to the hardware. Computers are digital systems, or actually synchronous digital systems ruled by a clock. Truth tables. So here is a truth table. So I will show you a truth table. And here is a Boolean, here is a logical expression. So it looks complicated, X or Y, or not X and not Y. Now, the purpose of this exercise is also to show that if you have such a convoluted logic in your programs, you should actually be very suspicious about what this actually is doing. So it's writing like this would be very bad code. This is a table that is typeset. I will actually explain how you solve this. So this is the raw input. So this is what you would type in. So Markdown provides a very specific syntax, a very easy way to typeset tables. We will see tables, another example of a table also in the second part of this session. It would not be wrong if you did this in any other way, so you can work with triple quotes and kind of with some ASCII formatting, also get to something acceptable. But if you typeset this, so if we go back to Markdown, then it neatly formats it. You also see the format, the outcome. So the outcome is actually true. So this entire Boolean expression evaluates to true. So if you have it in a condition, it's actually not a discriminating condition. So the if statement will always be true. So that is the conclusion of this exercise. So how do you solve this exercise? You must first start with the columns, one column for every variable. Two variables, you have two columns, two rows. So 2 to the power 2. Three variables, 8 rows, 2 to the power 3. How you enumerate all possibilities, there is somewhere um, for the outcome of the exercise, it doesn't really matter. But to work systematically, you can think in binary. So we started this review thinking in binary. So we have 2 bits, and we actually count from 0 to 3. So this is 0, 0, 1, 2, 3. So you enumerate like that. So we actually could already write a program that will print all the possible combinations that would actually do this. So for any number of variables, it would spit out the addition by 1. So this is a good programming exercise. But you should not solve this as a programming exercise. So this is important here. So again, it's important that you follow all the steps. So again, making the truth table, the conclusion is that everything evaluates to 1, 1, 1, 1, 1. This is true, but you must show the steps, how you got there. Again, it would be not wrong to work with false and true. But then mentally, with this binary summation here in the order, um, it is better like this as well. So let me show again the raw format. So not the raw format for the title. So the format for the, so you see that we have code and markdown, but if we want to edit, then we look at the raw format. So for every component in the logical expression, so we have x and y, x or y, you could do X or Y immediately. So the order of these columns here doesn't really matter. Here I chose to first do the not X and the not Y. You could eventually put the not X immediately after the X. And so the columns, you have some freedom there, although the last column should always be the entire expression. Again, it looks a lot of work, but working systematically, if you kind of miss a bit, then it would cost you only 1 point. It's kind of a calculation error. If you miss a bit and you don't show your work, then there are 4 bits here in the answer. It would cost you 1/4 of the entire points that are allotted for this question. Truth tables, Markdown, Jupyter Notebook. So this is all part of computer literacy. So the Jupyter Notebook is used also very frequently in data science, and we also use it in our other courses. So learning how to use a Jupyter Notebook properly is also something that will have some benefit later on. Okay, I'm halfway or I'm half an hour in. I have two questions left. Flowcharts and pseudocode. So we have the important problem of finding the maximum in a non-empty list of unsorted number. The mirror question is that instead of numbers we have words, and we want to sort the words are not ordered alphabetically, so it's a random order, and we want to find the word that comes first in the alphabetic order. So you can see we can quite easily, or the word that comes last. So there are many variations to this question. Um, Define the algorithm. I will first define the algorithm in words. So even if you wouldn't solve the actual question, you would actually already get credit for describing it in words. The list is not empty. If the list is empty, then somehow you have to be a little bit more, you have to think a little bit about how to initialize it then. So there is no first element. The maximum element, well, if their numbers are all positive, but you don't know this, if the numbers would be all positive, then you could initialize to a negative element. Um, because a negative element, whenever there isn't something else in there, it will be. So also -1, what is the maximum of an empty list? Can we define this? So, all right. So we say that the first element is the maximum element. We don't know any better. We only look at the first element. But then we change this. So as we go through the elements in the list, starting from the second element, we look at all the elements, and every time that the current element is larger than the current maximum, we have a new maximum. With pseudocode, you can be a little bit more flexible. So I was thinking in Python when I wrote the initialization. So part of the pseudocode is actually also let L denote the list. So it's good that all the symbols that you're using actually do have some meaning. So you actually, the M will actually be the maximum. So this pseudocode translates the algorithm. Um, I will show the flowchart. So here is the flowchart that I made with this diagram. You can do this in many ways. So you can start with the diamonds. That's how I did it. And I'm not doing this all that regularly, but I hope that you would have at least practice with one flowchart. So on the exam, I will most likely ask you for a flowchart. Um, um, just do it. When you submit it then, so the answer should be in a Jupyter notebook, but if you make a flowchart, you should actually also submit the diagram, the output of the diagram, this DIO file. I put it inside the Jupyter notebook because it's easier to scroll. So here you see, so I took a screenshot of it. If you are really in, and if you find that diagram too tedious to use, and you should, so you will have the entire session, which is 100 minutes. So 10 minutes should suffice per question. So you will have 9 or 10 questions. So you should budget some time. But if you lose your patience, You could eventually also draw it on paper real quick and take a screenshot and send also the PNG file. So that is kind of a last resort. But I would prefer that you would use the diagram tool in the Jupyter lab. Okay, the two diamonds are important. So these are the tests. So there is the stop test, the initialization. So the virtue of this flowchart is that it kind of forces you to think about the stop test. Here I used an other name of a variable n. It's okay if you put length of L here as well. Or you could eventually in words if at end of the list. But then it's kind of hard to think about the current element. You could, so this is not canonical. So you could have an additional statement here while not at the end of the list. If you're more verbal, you could have an extra element here, let X be the current element. So, and then go to the next element in the list. So it's perfectly fine to have entire, well, not entire sentences, but mostly defining what are the names of the variables, what you will be using. So I was already thinking in Python when I designed this exercise. So in some sense, flowcharts, they define algorithms. We often see them as a precursor to the Python code. But often when you know the flowchart is already precise enough to as an equivalent, to serve as an equivalent for the Python code. And in some sense, you will most likely in your career also use other languages. This is very much language neutral flowcharts. Okay, very good. So let's go to the last question. Formal languages. So formal languages only admit one interpretation, which is an important distinction from natural languages. Um, Remember again the unambiguous steps in the language in the definition of an algorithm. So um, the steps must be executable, but they also must be unambiguous. Okay, what are examples of syntax errors? In Python, we have the flexibility between single quotes and double quotes. It's a matter of style. Sometimes if you really want to emphasize, hey, this is a string, quote, double quote, so I'm just literally saying it. So then you may want to use a double quote, but what you shouldn't be doing is mixing and matching them. So you should not start with the right quote as I did here, and then start and then ending with a double quote. So you can also see that it is a syntax error. So it's really is something that the computer cannot or the Python interpreter cannot translate it into a valid statement. So a syntax error, I started up by examples because the point is it's what is a syntax error. So if you answer this question, you should come up with some kind of definition. It's good if your definition is reflecting a little bit what your example is. So you can always look it up, but again, you have to come up with an original example, and we have actually seen examples as well. So again, you have about 10 minutes to solve this question. You can look everything up, but you can also try to show really what you know, and that will often allow you to work a lot faster. Okay, so the hat symbol, and this is something coming from other languages. Python uses star star for the exponentiation, and you may want to think 2.3 to the power 4 is actually a valid um, operation. The syntax would work out, except that it's not really defined for a float and an int. So the type error here, um, a name error is also an example of a semantic error. So in the lectures, I gave an example where you had a name error. Um, Okay, so this is the first part of this 10th session on the review session for our midterm exam. There are 5 representative questions. Um, I also try to emphasize a little bit on how you should present your solution. It is possible if you are really not that familiar yet with Markdown, you can work with pictures, try to solve it on paper, and take clear pictures that you then upload. It would then be also very nice that you would use these things here, that when I grade this, that I don't have to um, switch too much. So it would still then be good to have one coherent Jupyter notebook with all your answers in there. Also, again, look at how tables are formatted. In the second half of this review, I will show another example.